Hi, this is Sunil from Hindran Engineering. As you are all aware, there are three popular configurations for a rooftop solar photovoltaic systems: the off-grid system, the on-grid system and the hybrid system. The on-grid system is a very popular configuration where the rooftop solar panels are connected to the utility meter and the loads are run by solar, and if there is any excess or deficit, it is managed by the DISCOM grids. In the off-grid system, the system is entirely cut off from the grid and the loads are serviced purely by solar panels and the batteries which are charged by the solar panels. Third configuration is called a hybrid configuration. It is a mixture of, or rather it is a combination of both the off-grid and the on-grid system. For the hybrid system, the presence of the grid is not mandatory to service the loads, so it is also called a grid agnostic system. There are different topologies possible in a hybrid system, which we will see now.
We will now see the different topologies in which the hybrid inverter works. In case 1, we have solar available. We also have the grid available. However, there is no load demand from the residents. In this case, the entire energy generated by the solar panels gets exported to the power utility grid. As you can see, the entire 1000 watts gets exported to the power utility grid and there is no energy import in this case. Now we will come to case 2. In case 2, we have solar available. We also have the grid available. However, the load is lesser than the solar generation. As you can see, the load is 400 watts while the solar generation is 1000 watts. In this case, the 400 watts of load demand is met by the solar panels. That is, out of the 1000 watts, 400 watts goes to the loads and the remaining 600 watts gets exported to the power utility grid. In this case, there is no import of energy from the utility grid. However, about 600 watts of energy gets exported to the power utility grid. In case 3, we have solar available. We also have the grid available and the load is higher than the solar generation. As you can see, the solar generation is 600 watts and the load demand is 1000 watts. In this case, the 600 watts of solar generation is servicing the loads and the balance 400 watts is taken by the power utility grid. So in this case, the 1000 watts of total demand is met by the combination of 600 watts of solar panels and 400 watts from the power utility grid. So in this case, we don't have any export of energy to the grid. However, 400 watts of energy is taken by the power utility grid. We will now come to case 4. Here, solar will be available, the grid is also available and the load is equal to the solar generation. So the solar generation is 1000 watts and the load is also 1000 watts. In this case, the entire load is serviced exclusively by the solar panel. So in this case, there is neither energy import nor energy export. Now we come to case 5. In case 5, solar is available, grid is not available, so there is no question of any export or import of energy from the power utility grid, and the load is equal to the solar generation. Here again, like in the previous case, the entire 1000 watts generated by the solar panels is servicing the loads. Now we will come to case 6. In case 6, solar is available, generating about 1000 watts. However, we don't have any grid available because of a shutdown. So there is no question of any import or export of energy to the power utility grid. And the load is lower than the solar generation. So the load is 600 watts while the solar available is 1000 watts. In this case, the 600 watts of load demand is serviced by the solar panels and the 400 watts goes to the battery for charging. Now we come to case 7. In case 7, we have solar available. We have grid absent, that is, there is a power shutdown and the load is higher than the solar generation. Say the demand is 1000 watts and solar generation is about 600 watts. In this case, the 600 watts of solar is servicing the loads and the balance 400 watts is coming from the battery bank. So the entire demand of 1000 watts is met by the combination of 600 watts of solar and 400 watts of battery. Now we come to case 8. In case 8, there is no solar available, so it's night time. So grid is also absent because of a power shutdown and the load is lesser or equivalent to the battery capacity. This is the case in which the design comes into picture. So the design has to be in such a way that the load never exceeds the battery capacity. So as you can see in this case, the load is lesser than the battery capacity. In this case, since there is neither solar nor grid available, the entire demand of 600 watts is serviced exclusively by the battery bank. It is very important to know the energy stored in the battery bank. We will try to calculate for a particular case how much energy can be stored in the battery bank. Say we have a battery size of 200 Ah, 12 volts battery. Like that we have got 4 batteries. So the battery bank voltage becomes 48 volts. So the total available energy from the battery bank is given by 200 Ah into 48 volts into 75%. That is 75% is the depth of the cell. So this is equivalent to 7.2 units or 7.2 kilowatt hours. So in the case where there is neither solar nor grid, the battery bank can at maximum supply about 7.2 units of energy. Thank you very much.